So this circle versus triangle part starts here with a laundry chute door and a laundry chute, which is a circle 24 inches in diameter. It's really easy to measure it accurately. You just have to fetch the tape measure. Yep, 24 inches to the edge of the circle. So that's the circle part. The triangle part comes in here and is formed by the door closer. Two sides of the triangle are the door closer. The third is an invisible third side. So that's how the door closer, of course, work. And the problem is that the point of the triangle rips the laundry bags because it protrudes too far into the circle. Yes, every single bag is torn. It is somewhat of a problem. So is there a solution? The door is at 90 degrees to the circle, to the laundry chute. And here we have, before we reach the circle here, we have here also a distance. And we have 30.5 here to the edge of the door. This can be duplicated and laid out. We have a length of this door. We have an offset distance. We have a circle. I'm going to go to the shop and show you what I have in mind with layout. Now the millwrights try to do their best and shorten this arm on the triangle. You see this one has been cut down and modified, and this is the original length. And yes, the original is ripping the bags and the cut down version is still ripping the bags. So the question is it at all possible to squeeze in the closer arm in that space that we have and not have it protrude into the chute? So here's the same laundry chute duplicated in the shop. Obviously I have a diameter of 24, so a radius of 12. That's the laundry chute. Then the door opening starts at 30.5 inches, so the door takes up space somewhere there. This is the inner surface of the door. The outside of the door would be here with the handle on it, opening this way, rotating at that corner. And the door's width is 20 inches, and this here forms a rectangle that intersects the circle like so. And the last number that we need is that the pivot point for the center of this spindle on the door closer, where the closer arm mounts, is 1 inch away from the surface of the door. Just roughly, the door closer is mounted pretty close to the pivot point or the hinge, but it could be mounted anywhere along the surface of the door. It could be mounted over here to the inside, obviously 1 inch away, so just roughly 1 inch away there. And this can be mounted anywhere along this side wall. Is there a point or is there a configuration where any part of this triangle is not inside the circle? We could try it here, we could try it here. You see it's getting worse and worse, more and more of the closer arm inside the circle. We can try mounting this leg somewhere here and repeat the experiment. Yeah, it's not looking good. This can be shortened. Let's try that. So the threaded section here has been shortened by 4 inches, as much as it goes. And if that one's mounted on the side wall there, and this is still in the same spot roughly there, it's still, much of it is still inside the chute. And wherever I place this arm here, the situation or the overlap here is not really improving significantly. Let's try the other corner here. That's a little bit better, but at no point is this elbow not going to be inside the circle. So that's the long arm. So let's see the short arm, where this can be shortened, as well as the millwright shortened the length of this arm. Let's see how that works. And it looks like the shortened arm here does the trick. This is just glancing the edge of the circle there and can be about that far away to function, and this point can be moved here. Now I see that this one is extending, so just gonna shorten it back. That's yeah, that's still inside the circle, so the triangles are still winning, but if it's somewhere here, somewhere in the middle, whatever, there can be a sweet spot, like this one works pretty well, or somewhere further along the door. So it looks like this corner works well for this mounting point, and this short arm in the corner here where it's like possible to make it work. And this short arm then can be almost pretty much anywhere. It's gonna work well enough to keep it out of the circle.